Alright, this video is on what's known as Pascal's principle. I guess it's a third video in Unit 9. I like to call it the bottle jack question, but anyway, it's the principles behind hydraulics. Pascal's principle, and if you want to write this definition, it's Pascal's principle says pressure is transmitted unchanged in a fluid, which means if you know the pressure in here is like 50 psi, the pressure here should be 50 psi. The pressure here, here. The pressure anywhere in here should be 50 psi. That is Pascal's. Ooh, liquid paper. I forgot that was sticky. Pascal's principle. The most basic problem looks like this. You've got two cylinders, and I've got two round cylinders here. One small one, one large round cylinder. The cylinder on the left, I've got an area of 1 meter square. The cylinder on the right has an area of 3 meters square. And to some degree, this should almost make common sense. This is the principles behind how a hydraulic jack works. It has two cylinders. You exert a force on the smaller one. In turn, you're able to lift something up with the larger cylinder. So let's see if we can't figure out a little bit how this works. So let's say we've got a smaller cylinder over here. And let's say we exert a force of 10 newtons upon that cylinder. Well, I want you to look at something. What would the pressure on that cylinder be? Well, pressure is force over area. I always write my equations because that way I'll remember them. So this is 10 divided by 1. So that's a pressure of 10 newtons per meter square. Except I forgot to write the number 10. But anyway, so that's a pressure of 10. So I'm putting 10 newtons. Now this is where this makes sense. That means the pressure anywhere inside here at this point should be 10 Newton per meter square. The pressure at this point should be 10 Newton per meter square. There should be 10 newtons on every meter square of this fluid, and that's what's inside here is a hydraulic fluid. So there's 10. That pressure is unchanged inside here, which means there's also 10 newtons per meter square being exerted on this other piston. And now let's just use common sense. At this point, if this piston is 3 meters square, that means you've got 10 newtons for every meter square. So you've got 10, 10, and 10, meaning that this one has a force of 30 newtons coming out of it. So you have tripled the force output that you've put into the cylinder. Now, obviously, we've got to have an equation for it. And all you got to do is think, what is it that stays the same? The pressure here is the same as the pressure on here. So the pressure on cylinder 1 has got to be equal to the pressure on cylinder 2, which means the equation we would then use is, I'll write F1 over A1 equals F2 over A2. And it really doesn't not matter whatsoever which cylinder I call 1, which cylinder I call 2, as long as you got them grouped. Like here, the 10 and the 1 go together. That would be the only thing that's important in working these problems. Now, a lot of times in these problems, they won't give you areas. They'll actually go in and give you a radius. If the problem gives you a radius, that's no big deal. How do you find the area of a cylinder? What's pi r squared? So you'd write F1 over pi r squared equals F2 over pi r squared. And let's put in our 1s and our 2s to make it very textbookish. I'm actually way too lazy. I just write F over A equals F over A. Look what happens to your pi's. You cancel your pi out and you're left with F1 over r squared equals F2 over r squared. This is all you need really to get started in Pascal problems. Let's go ahead and work one that we've actually got via the textbook, Serway and Fawn's 7th edition that we're currently using. In a car lift, compressed air exerts a force on the piston with a radius of 5 centimeters. The pressure is transmitted to a second piston of radius. So here you go, right off the bat. You see that this problem's got the two radiuses in here. And so you're already, all right, this is going to be an F over A equals F over A question. So I'm going to go ahead and write F over A equals F over A. It's a basic proportion. It gave me radius. Well, I'm just going to go ahead and do a little substitution. That would be F over pi r squared equals F over pi r squared, and the pi's cancel. So F over r squared equals F over r squared. It doesn't matter really what you call 1 and 2, whether it's 5 or 15. It just matters this. It gave you the weight of the car. Does that weight, which that weight will be my force, does this weight go with the 5 centimeter or the 15 centimeter radius cylinder? What force must the compressed air exert in order to lift the car weighing 1.3? So the car is sitting on top of the second cylinder. Now I want you to notice something. F over 5 squared equals 1.33 times 10 to the 4 over 15 squared. I never even changed out of centimeters. Oh no, that's horrible. No, it's a proportion, so my units didn't matter. And if I want the answer, all I got to do is cross multiply and divide. So we'll just go into the old TI here. 1.33 second to the 4th times 5 squared divided by the bottom, which is 15 squared. And that's 1477. So I've got a force of 1478 newtons being exerted on the first piston. And that is all there is to doing one of these type of questions. Car lift questions, a Pascal's problem. I know a lot of times they like a very common problem you'll see. I'll throw this out. A lot of textbooks will give you this problem. They'll give you like a car, and they'll have the wheel and the brake drum on there. So this is like the edge of the wheel, and so here is the brake drum, and it'll have a piston inside here. And cars really are made this way. And here's that piston inside here. And when you push on the brake pedal, so somewhere else in the car there's a brake pedal, which is also pushing on a cylinder. And they're connected via a fluid. And so when you squeeze down on that brake pedal, when you exert that force on that brake pedal, it also exerts a force on this brake shoe, which then pushes against your tire. So a lot of problems will then, this is a very common question, they will try and give you information. This thing over here is nothing but an F over A equals F over A question. And then since Unit 8, you did those problems with like torque, they'll try and make it FR equals I alpha kind of a question. And so you'll find a force, but this is what blows everybody's mind. See, the tire is rotating like this. And so it's actually friction that's stopping the tire. So really it's little fr equals I alpha is the trick to that problem. And here's the thing. If this is friction, friction is mu n, what's n? You can't even read. This force is my normal force. So what you end up doing is friction is mu n r equals I alpha. And so what you'll do is find this force and use it for your normal force in this equation. So that force becomes your normal force. And that's where it tries to put this problem together. And this is found in almost all textbooks. So it's kind of a common question. Matter of fact, I'll go and tell you, it'll probably be the bonus on the next test. So a little bit of an idea there for this. So F over A equals F over A. Do your FRI alpha. It's friction stopping the wheel. Friction's mu n. And that force is your normal force for this part over here. But anyway, I feel good about you. Y'all go have fun working these problems.